So welcome to the chapter that is called as the acceptance sampling, and it is a sixth unit, and we are in the session 6 right now. So here we'll be dealing with some of the problems here. So, and after once again the course outcomes is nothing but after the completion of this unit 6, the students will be able to understand the basic concepts of the acceptance sampling. So in the previous, that is in the session 5, we have discussed some of the problems on the OC curve and the constructions of the OC curve by the calculations. So here in this session also we are dealing with the constructions of the OC curve by means of the calculations as well as by means of calculating it, drawing the OC curve by using the statistical quality control tools. So next, so we'll take a problem here once again. A shipment of 2000 portable battery units for the microcomputers is about to be inspected by a Malaysian importer. The Korean manufacturer and the importer have set up a sampling plan in which the risk is limited to 5% at an acceptable quality level. At AQL, it is 5% of 2% of defectives, and the risk is set to 10% of the tolerance percentage defective, that is LTPD, that is the 7%. And they have fixed AQL, that is the 5%, and the LTPD, that is the 7%. So we want to construct the OC curve for a plan of n is equals to, small n is equals to 120, that is the sample size, and the acceptance level C is equals to, either it is equals to or less than 3 defectives. So both firms wants to know if this plan will satisfy their quality and risk requirements. So this is a problem here. So here the shipment will be around 2000 items will be shipped, and out of that they have selected n, small n, that is the sample size is equals to 120, and they have set up the value of the AQL, acceptable quality level, that is 5%, and the lot tolerances percentage defective, that is the 10%, with the 2% of the defective. Here the manufacturer says that this shipment may contains the 2% of the defectives, and here we need to construct an OC curve for the plan n is equals to, small n is equals to 120, and the acceptance sampling will be equals to less than, equals or less than the 3. So it means that we need to find out the acceptance acceptance value for the 0 defectives, for 1 defective, 2 defective, and 3 defectives. So with this, we can start the problem here. So now to solve the problem, we return to the cumulative Poisson's uh, distribution table 3, appendix 2 of the text, whose columns are set up in terms of the acceptance level C. We are interested only in C is equals to 20 column for this example. So this rows in the table, that is n into P. So with the C is equals to, we have to search the values of the probability of the acceptance. So we can find out that value with C is equals to 3 and NP is equals to, and with the C and also with NP value, which represent the number of the defects would expect it to find in the sample. So by varying the percentage of the defective P, we have to vary from 0.01 to 0.08. That is 1% to 8%. We have to take the values. So it means that we have to find out the percentage of the acceptancy for P is equals to 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And holding the sample size n is equals to 120, we compute the probability of the acceptance of the lot at each chosen level. So the values of the P acceptance calculated in that what follows are the plotted to produce the OC curve as shown in the figure. Next slide, you will see the figure. Now, following data is obtained from the table for NP and C. See here. So NP is the value, so we can calculate it here. We have to take P first, we have to take the P values. So we have to start because the P, we have to construct the, you can see here, we have to construct the OC curve by taking the P value from 0.01 to 0.08. So let us construct the table with the column showing P, NP and PA. So where the P value will start from 0.01 to 0.02, 0.03, then 0.04, 0.05, 0.06, 0.07, and 0.08. So after taking the P, we know the value of N. N is equals to 120. In the second column, the second column shows NP value. So P value for the first row, you can see here the P value for the first row, it is 0.01 into N is 120. For all these values 0.01, 0.02, 0.03 and 0.04, etc., etc., 0.08, till that we need to multiply these values with the sample size that is equals to 120. Here you can see all these values has been multiplied. So then we are going to get the value of NP. So NP is equals to here 1.2, 2.4, 3.6, 4.8, 6, 7.2, 8.4, and 9.6. So then with the value of NP is equals to 1.2 and C is equals to 3, you can see here the value of the C has been given. So it is C. This is the value. C is equals to 3. So from the table, with the NP is equals to 1.2, C is equals to 3, we will get 0.966. We will get 0.966. So now with the NP value is equals to 2.4 and C is equals to 4 from the table, so we will get 0.779. For NP is equals to 3.6, 3.6, and P is equals to, sorry, NP is equals to 3.6 and C is equals to 3, we will get the value 0.515, and NP is equals to 4.8. NP is equals to 4.8 and C is equals to 3. We will get the value 0.294. Then NP is equals to 6. NP is equals to 6 and C is equals to 3. We will get the value 0.152. So then NP is equals to 0.7 and C is equals to, the NP is equals to 7.2 and C is equals to 3. We will get the value 0.072. Next, for NP is equals to 8.4 and C is equals to 3. So we will get the value 0.032. Then for the NP is equals to 9.6 and C is equals to 3, we will get the value 0.014. And here you can see that, so it has been alpha AQL, okay. So 1 minus alpha it should be a 1 minus alpha, that is the AQL. AQL is the 1%. You can see AQL is 1%. You can see in the problem AQL, that is the acceptable quality level, will be uh, it is the risk of that is 1%, and this LTPD is the 7% here. You can see. So you can see that one. So for the 1%, say for this one 0.01. So this is the at AQL, that is called as the 1 minus alpha, that is called as the acceptable quality level. So this is the acceptable quality level. 0.966 is the acceptable quality level, and then the 7.7%, 0.07, here it is. So that is the 0.032 is the LTPD here. So the LTPD is 0.032. So now after fixing these values, so we can construct, when you construct the curve, so you are going to get the OC curve. So now this is the OC curve that we have constructed by taking the values of, the PA and NP from the table. So it is not the calculations done with the, here it is the, where we have not got these values by means of the calculations. Here we got these values by means of the samples, sorry, from the table, not by means of the calculation. So now here we will discuss the what exactly that is happening here with this, whether it is applicable, whether this plan is applicable or not. So now back to the issue of whether the OC curve satisfy the quality and the risk needed of the customer and the producers of the battery. So now we have to think whether we are going to get, whether with this plan, with this OC curve, whatever the OC curve that we have drawn, so whether that OC curve fits for the consumer and the producer. For the AQL, P is equals to 0.2, 2% defective, P is equals to 2% defective, and the lot 0.799. So this risk yields 1.779, that is 22.1%, and which exceeds this 22.1% risk. It exceeds the 5% level, because they have decided already, AQL should be 5%. You can see here in the problem, they have fixed AQL is equals to 5%. You can see here. So the AQL is equals to 5% and LTPD is equals to 7%. Now you see here. So now the risk, it is what, 22%, so which is exceeding the 5%, so it is not fitting now, so desired by the producer. So this plan, it is not fitting for the producer. Now this, the risk of 0. That is 0.032 or 3% is well under the 10%, so sought by the consumer. So it appears that new calculations are necessary with a larger sample size if the level is to be lowered. So in example, we set the values of N and C for the sampling plan and then compute the risks to see whether they are within the level or not. Often organization, instead developing an OC curve for preset values, an AQL, and then submit the values of N and C until the plan satisfied the LTPD demands. So here the meaning is that, so according to the curve, okay, so we should get the this thing, the AQL, it should be less than the 5%. According to the agreement between the producer and the customer, the AQL should be 5% and LTPD should be the 7%. But here we are getting 22%, so which is more than the 5%, so which is not satisfying the customer, the producer, as well as it is not satisfying the customers. So because it is customers, for customer it is 10%. So we are, it is not satisfying both the customer and the producer. So they need to change the values and they need to find out the things. So the next one is, so using the formula with n is equals to 52, c is equals to 3. So then p is equals to 0 0.1, 0 0.02 till 1.2. So plot the OC curve. So now here, see here we have to take the values of NP, P, and PA. We need to find out. So we have to take. He has given the values of the P. So 0 0.01, 0 0.02, 0 0.03 till 0 0.12. We need to go. See here, 0 0.01, 0 0.02 till 1.2. We need to go. So we need to go till 0.12, and for that, if this is the value of the p, when you multiply this p by n, so we will get 0.5. So for the value of n, p is equals to 0.5, and c is equals to 3. You can see here c is equals to 3 from the table. Np is equals to 0.5, np is equals to 0.5, and c is equals to 3. We will get pa is equals to 0.998, and for the value of np is equals to 1, so we c is equals to 3. We will get the value pa is equals to 0.98. So what we have to do is we have to multiply these values, that is 0.01, 0.02, 0.03, 0.04, 0.05, 6, 7, 8, 9, 10, 0.11, 0.12. All these values we need to multiply with the sample. So when you multiply with the sample size, you are going to get the value of NP. With C is equals to 3, with these values, we can get all the values. Now we need to plot the P versus PA. So when you plot P versus PA, you are going to get a curve that is called as the OC curve here. So, so the next we'll take another problem here. An OC curve drawn for a sample of n is equals to 300, c is equals to 10 at the figure indicating the following. Here he has given the AQL. AQL is the 2% for the producers. Manufacturers risk is 0.05. Consumers risk is 0.1, and LTPD is 0.05. For n is equals to 300 and p is equals to 0.1. So what, we can calculate all those things and we can draw the curve here. So now see here. So for n is equals to 300 and p is equals to 0.01. So p is equals to 0.01. So once again in the formula, that is NCXP to the power of x into bracket 1 minus p, 1 minus p into the to the power of n minus x. So this is a formula where x starts from 0 and it will end at 10, because the c value is how much here? It is 10. Because c is 10 here, so the x value will vary from 0 to 10. So in this formula, now n is equals to 300, n is equals to 300, and p is equals to 0.01. So x in the formula, x will remains as it is. So when you need to create this formula, you create this formula in the calculator. We can create the formula in the calculator. When you put this value, n is equals to 300, c as it is, and p is equals to 0.01. So you will get the value that is equals to 0.9997. So that is the 0.9997 is the value for n is equals to 300, p is equals to 0.01, where x tends from 0 to 10. So now similarly, for n is equals to 300, sample size will remain same. Only the value of the p will vary. So now the p is varying from 0.01 now to 0.02. Once again, when you take the formula, so x tends from 0 to 10, n is equals to 300 cx 0.02 to the power of x into 1 minus 0.02 to the power of 300 minus x. So we will get 0.9590. So 0.9590 is the value of the probability of the acceptance for n is equals to 300 and p is equals to 0.02. Similarly, then you can increase the value of the p from 0.0. Now we have increased the value from 0.01 to 0.02. Now we have to increase it from 0.02 to 0.03. For p is equals to 0.03, x varies from 0 to 10, n is 300 c x, you keep it as it is, p is equals to 0.03 to the power of x into 1 minus 0.03 to the power of 300 minus x. So we will get the value from the calculator. It is 0.7078. So now see here, we got with this slide, we got the value of the PA will be 0.9997 for P is equals to 0.01, 0.9590, 0.9590. We got the value, that value for the P is equals to 0.02 and 0.7078. We got this value for P is equals to 0.03. Now we can get, say, now I have varied the value, that is p is equals to 0.04. For p is equals to 0.04, I got the value that is 0.3429, and similarly for p is equals to 0.05, so we got the value 0.1123, and p is equals to 0.06, we got the value 0.0268. So then all these values we need to tabulate it, and when you tabulate it and when you draw, so you have to take the values of, okay, that is p accept probability of the acceptance, okay. So that is when you draw it, so you will get a curve, so that curve is called as the OC curve. So these are the probability of the acceptance. So here these values, so now you need to tabulate these values here for 0.01. For 0.01 you should take p is equals pa is equals to 0.997. So like that, for 0.02 it is 0.9590. so like that you have to tabulate, and then you will get the curve that is called as the OC curve. So you see here uh, the first value 0.997 for the PA is equal to 0.01. From the curve you can see here 0.997. So for the value of, that is, P is equal to 0.01. So this is correct. So the next value you can see it is 0.9590. So 0.9590. So it is for 0.0. P is equals to 0.02. It is 0.9590. So next value, that is equals to 0.7078. So that is the value for 0.03. For 0.03, so this is the value we are getting here at this point. Next, for 0.04, 3429, 3429 for the 0.04, 0.04, 3429. For 0.05, it is 1123. It is 1123 for 0.05. Next, for 0.06, it is 0.0268. So it is 0.0268. So now you can see that this is the curve that has been drawn. So this is the curve that we got here, OC curve. We got this one by means of the calculations. So I can say that once again, I can say that the curve can be drawn, the curve can be drawn either by means of the calculation, by means of the calculations where we need to use a formula sum of x, sum of x tends from 0 to n, and where n cx into p to the power of x into bracket 1 minus p to the power of n minus x. So we need to use this formula, and we need to create this formula in the calculator. And by creating the formula in the calculator, just by putting the values of the p, that is equals to 0 0.01, 0 0.02, 0 0.03, 0 0.04, 0 0.05, 0 0.06, like that. If you proceed, so you will get the value of the PA. So you need to draw the curve with that values. So when you draw the curve, so you will get all these points here, and that's how we can construct the OC curve here. So once again, this is the session. So this session I have covered the I have covered the some of the problems on the basis of the calculations, and some of the problems I have covered on the basis of by using the tabular column. See here, it is the manufacturer's risk is 0.5, and the consumer's risk is it is 0.01 at at AQL 2%. You can see here AQL is 2%. 2% is the AQL that has been given. So when you draw a line, it is meeting at the curve at this point, and the difference of in the curve, it is the it is it is called as the manufacturer's risk, and this difference is 0. Uh, this difference is 0.5. So here you can see that 0.9521. So this difference will be 0.5. So that is the manufacturer's risk. Next, the bad quality LTPD, it has been given 5. So from the 5, you draw a line here. So this line, draw a line when it meets the curve at this point. Draw the horizontal line here. So here it is presenting, it is showing almost very close to 0.1. You can see here this is 0.1. So this risk is the consumer's risk. So like that, we can find out the consumer's risk and the manufacturer's risk with the help of the OC curve. So thank you very much.